Today we're talking about a couple different integration techniques, and so we're just going to expand the types of functions we can integrate. And today we're looking at a special technique called integration by parts. And this integration technique is useful in finding integrals involving products. Okay? And you can see a couple of them here. X ln x dx, x e to the x squared sine x, and x squared e to the x. Now a lot of these are going to have transcendental functions combined with normal functions. So you can see here, this would be, we don't have any way to integrate this right now because there's no u du type of situation. So when we do this, we're going to have a function. Okay, so one function and the derivative of another function. So that's what we're looking for, a function and then the derivative of a second function. Now the way this works, integration by parts is derived from the product rule for differentiation. So you can see the product there. And so let's see if we remember what the product rule is. So the derivative of u times v, u and v both being functions. So remember it's the first function times the derivative of the second. Second function times the derivative of the first. Now what we're going to do here is actually integrate both sides. Okay? So we're going to integrate both sides.
Wait, so we're deriving it and integrating it?
Yep.
Is that the same thing as doing nothing?
Kind of. So let's integrate both sides. Alright, so that's just the left side, which is just uv.
Would it be uv prime? Oh, the integral of the derivative of prime.
It's been a while. Huh? Okay, so we integrated both sides there. And so in algebra, what do you do to one side? You do to the other side, and we know we're still okay. Now, for the integral of the derivative, okay, cancel each other out. So now we're just left with uv equals. Now, v prime dx, that's the derivative of the second function right there. And so what we really have here is u dv. Okay, and then plus the integral of v, and then u prime dx is just du. Now, what we were looking for, remember, is the integral of a function times the derivative of the second function. So what we're going to do here is go ahead and just solve for this one right here.
Wait, going back a little bit, where did you get u dv from? It's because u prime dx, is dx saying integrated, right?
Yeah, so v prime dx.
So the dx and the v prime cancel out. The only thing I'm not seeing is where dv comes from.
That's the v prime dx. Because remember the derivative of any function will always have that dx at the end?
Yeah.
So that's just the dx at the end. So we can just say it dv instead. So the derivative of v is v prime dx. It's the same thing. Remember using the chain rule?
Yeah.
So you have the function v, and you take its derivative, but then you still have the dx part.
Okay.
And we can just simplify that by saying dv.
Sure, I see what you're saying.
All right? And so then the same thing happens here. U prime dx, we can just write du. Okay, everybody clear up to that point? So then the next thing we have to do, we're solving for the integral of the function times the derivative of a second function. So u dv. And so we subtract, okay, the integral of v du to the other side. And so there we go. Now we know the integral of u dv equals u times v minus the integral of v du. And there it is. Looks kind of complicated, but once we go through some problems, it should be okay.
Yeah.
So the trick with a lot of integration is deciding what part of your function is going to be u, and then what part of the function will be dv. So first off, let's just talk about dv. It says, try letting dv be the most complicated portion of the integrand that fits a basic integration rule. Then u is going to be the rest of the stuff. Okay? So basically, what you're going to be asking yourself is, okay, for dv, can you integrate easily? Okay, so when you're picking dv, can you integrate dv easily? Okay. Now the next one is by deciding what u should be. So try letting u be the portion of the integrand whose derivative is a function simpler than u. So we just say, is du simpler than u? That's where we're going. So the whole point of this is we're trying to simplify everything. So if we pick a u and its derivative is more simple, then that's probably a good choice for choosing u, because it's going to simplify things. So let's take a look at our first example. And I just want to write out all the possibilities for u and dv. And then we'll kind of discuss which one we want to use. So first off, we could let u equal x. Then dv would be all the rest of the stuff. So e to the x dx. Or u could equal e to the x, and that would make dv all the rest of this stuff, which would be x dx.
Yes.
Or, here's a weird one, u could actually equal 1.
What?
Yep.
I guess. I mean,
In that case, dv would be x e to the x dx.
that's an interesting way to do it.
Or there's one other possibility,
Not really.
x e to the x, and then dv would equal dx. So which one do we want to use?
I think the first e to the x.
Okay, we're actually going to choose the first one.
No.
Okay, so let's look at this. For dv, can you integrate e to the x dx easily?
Yes.
Yeah, that's very easy.
Turns to the x.
Turns to e to the x. Okay, now if u equals x, is the derivative of u simpler than x?
Yeah.
What's the derivative of x?
1.
1. Is 1 simpler than x?
Yes.
Yeah, it is. So this is probably our best choice right there. So when you write out this, we also need to find du, which is just 1 dx. And then we're going to integrate e to the x dx, which is just e to the x.
Wait,
Okay. So you need to pick your u and your dv, and then find du and v.
and to find v, all we did was
Integrate dv.
we integrated it?
hmm
Okay.
The antiderivative.
Because that's right there is a,
So this is the derivative,
that's the derivative.
and we want to find the antiderivative v. So you need to derive and integrate there.
Right.
Now, let's take a look at our formula here. Remember, it was uv minus the integral of v du.
That's u. Oh, u is x.
Okay, now notice we had to find uv and du. It's all over here. So we're going to substitute it in. So u is x,
X e x.
and then v is e to the x.
So where did we get v? Oh, v is e to the x.
Okay. Minus the integral of v du. So v is e to the x, and then du is 1 dx. So we can just write dx.
All right then.
Okay, so here we substituted. And now let's go ahead and integrate.
Oh boy.
So x e to the x just stays. And the integral of e to the x is e to the x. And then, because this is a whole family of functions, plus c. So indefinite integral, we have the plus c.
I can't determine if that's easy or hard.
I think the guessing is tough.
Okay,
Yeah, that's the hardest part.
so there we go. Let's try another one.
Oh boy.
Now we're not going to write out all the possibilities every time. We're just going to think about it and come up with our conclusion.
U should be x squared. Right? Yeah. Whatever is more simple should be du.
Okay? So let's think about this. If we look at x squared, we can find its derivative, and it is simpler. If we look at ln x, can we find its derivative? It's 1 over x, and that's also simpler. So that's
Should we do either one?
kind of a toss-up right now.
Let's
So
just do x squared because that's easy.
let's look at our dv part. Can you integrate easily? Which one's easier to integrate, x squared or ln x?
L and X? I think L and
Well, they're both easy.
I think x squared is going to be easier. Like, think about the order that we learned them in.
Yeah.
We started with the most simple, right? The power rule. And so we're actually going to let u equal ln x. And then dv,
Wait, can you spell?
which we learned how to
Wait.
derive the integral.
I thought DV was the more complicated one.
The u has to be the one that we can integrate easier.
so
Use derive easy.
U is derive easier, dv is integrate easier.
Oh,
yeah,
Okay.
We can
yeah.
divide
dv is integrate easy.
Okay.
And it may work out both ways.
Okay.
So we'll just try that. So we also need to find now du, which is 1 over x dx. And we need to find v, which is x cubed over 3.
And then we plug it in the formula and we're done.
Then we plug it in and we're done. Yep.
Okay.
So we have uv, and then minus the integral of v du, x cubed over 3,
That just goes back to being x squared.
and then du is 1 over
X
x
squared.
dx. And you can see here we can simplify the integrand. All right, x cubed over x is just going to leave us with
No, it turns into x squared again.
x squared. And we can pull out the 1/3.
Oh, 1/3. Oh, it doesn't really matter.
And then we can clean this up a little bit. Usually we'll put the x cubed first.
We have to
Okay.
pull the 1/3 out, or
You don't have to.
Just
no?
been doing.
I don't want to.
All right, so if we integrate x squared, we get x cubed over 3. And then we'll simplify here. Plus c. Right? All right,
Okay.
well, let's move on. All right, x squared sine x. So u, we think about an easy derivative. Let's just try x squared. Okay, and that would make dv sine x dx. Now we find du, which is 2x dx. And then we find v by integrating sine x,
I turned it into negative.
negative cosine x. Okay. And then we just plug it in the formula like you said. So uv minus the integral of v du Now we can take out the negative, so we'll do that,
So that just becomes
plus the integral of 2x cosine x dx. Now when you look at this, can you integrate 2x cosine x? Do we have a function and then the derivative of another function? A second function?
Like, you do it again. So it'd be x, oh, that'd be x times sine x.
Notice we're taking the integral of a product.
We have to do the same thing again? Oh dear.
So exactly.
Oh, God.
We're going to use integration by parts a second time.
But it has.
So we put the 2 out first, or does the 2 have to stay?
So what I do is I just label this as my first integration by parts, and then I make a second integration by parts. And so now we want to integrate 2x cosine x. So now notice it's a little bit simpler than it was though. You see that?
Yeah.
Because we had x squared before as u, and now u is going to be 2x.
Did that happen because of the exponent? Or
So the exponent means we're going to have to do this another time. Okay, so u equals 2x. dv
cosine x dx.
cosine x dx. du equals 2. Notice that's getting even more simple. Now we're down to just 2 dx. And integrate cosine x, that's easily done, right?
Sine.
Sine x. Now, in this process, we don't want to lose our original uv, right? That's still part of our answer.
So that means parentheses tagged on to the plus.
Yeah, so we're just going to tag that on there.
This is ridiculous.
And then here is going to be our second integration by parts. So now we have uv, which is 2x sine x, minus the integral of v du, which is sine x dx. Oh, there's a 2, huh?
2 sine x dx.
So would it be,
There we go.
since that is the integral, we don't need the integral in front of it in red?
Wait, we have the integration of the thing in red.
Yeah, this is the second integration.
No, that is the integration.
That's the integration of this.
Oh, okay, yeah. So we just box that?
Nope, we're not done yet. Okay.
No, I mean close the thing. I meant close the box.
Yeah, right there.
Yeah, like AP. Not box.
And then the integral of this,
Cosine x.
Does the 2 just stay there? Does the 2 just stay there?
well, a 2 would come out,
And then you just tag it on.
and then the integral of sine is negative cosine. So it's a double negative, making it positive. And then at the end, plus c. And there we go.
It's not hard. It's just
Annoying.
Annoying,
that's the word.
Tedious.
but powerful.
Is it?
All right, let's try our next one.
X cosine. That one's easier.
So u
That's
Yeah,
what we
it's
did.
last. Do you think it's gonna be?
is x,
It looks easy.
dv cosine x
Yeah.
dx. du is 1 dx. And v is sine x.
Okay, so UV.
So uv
Sine.
x sine x minus integral v du, which is just sine x dx.
Just like before.
What's he gonna do with blue? Probably a third.
The integral of sine x is just negative cosine.
Hey, integral sine is negative cosine. Then you're double negative there. So that one was just 1. Done deal. All right, let's go ahead and turn the page. Now, down here at the bottom, I've kind of put a summary little cheat sheet for you of common choices for your integration by parts. So these all have an x to the n, and then with e, sine, and cosine. In this case, you're going to let u be x to the n. Okay? In this case, here we have an x to the n, but it's paired with ln, natural log. In this case, we kind of go with u is going to equal ln. Okay? So that's the one where we want u to be ln. And we have a couple that have e and sine, or e and cosine. In this case, you're going to let u be sine or cosine. That's kind of your cheat sheet there. So looking at this one, letter E, what do we let u equal? Based on our cheat sheet down there. X squared. Good. See how it's x to the n times e to the ax? Okay, and then dv is going to be everything else. So e to the 2x dx. And then du is 2x dx. Now v, so the integral is e to the 2x, but then we still have that 2, so it's going to have to be 1/2.
E just stays the same.
E stays the same, but then you have to remember to divide by whatever that is. Because remember, you have the u du, and so you have to take out. So du is 2, so you have to put a 1/2 on the outside of the integral.
Yeah, I sound like that.
Yeah? Gotta remember that?
You just start doing it.
And then we start doing it.
It's u and then du. No, the first one is u and v, right?
uv,
Yeah.
and then vdu. And you're going to see the 1/2 and the 2 cancel here.
Oh, that's cool.
So that's nice.
So it's integral e to 2x times x, which is another one.
Okay, and you can see again we still have that product. So we're going to do integration by parts a second time. So again, I just put a little 1 there, and then for this I'll put a little 2. So here u is going to be x.
dv is e to the 2x dx.
Yep.
To integrate that, we just throw it in.
And notice the integration is the same.
Yeah, pretty much. Except the x turns into a 1.
So it simplifies it down. Okay. We bring down the uv, the 1/2, x squared e to the 2x. Now minus, we want to make sure we subtract this whole integral.
The inside of the integral is u du, dv, or is it
v du.
v du? Okay.
Okay, so we'll distribute the negative here. So that's minus 1/2 x e to the 2x.
Oh, you both said that one. That's cool. At the end anyway.
And then here, so we already have the 1/2. Oh, but the du is 2. So we need another 1/2, making it 1/4. So this is going to be minus 1/4 e to the 2x plus c.
And then we can pull out some stuff, right?
I think we could just leave it, because you can't pull anything out because of the plus c.
Oh, that's true.
I mean, it wouldn't be helpful. So we'll just leave it.
That's not that bad.
Not too bad. Letter F. All right, let's give this one a go. So for you, which one gets the derivative here that's going to be simpler? X. Because 1 is simpler than x.
dv equals secant squared dx.
Mm-hmm. Du, that's nice. 1 dx.
dv is equals secant turned into, oh boy, it's that thingy, right?
Doesn't it turn into secant x tan x?
No,
Or
it's
no,
that
that's
one
the
thing.
other way.
It's that one thing he taught us. That one.
This one is just tan x.
What? We don't have no. This is gonna be a one step.
Tan x.
This is going to be a one-stepper. UV.
So x tan x minus v and du.
So VDU,
Negative secant squared.
tan x dx. Integral of tan. Oh, look in the inside cover of your book.
Secant tangent.
Oh, integral.
Think about it. Tangent is sine over cosine. Then do you have u prime over u, which is natural log. Right? Remember that?
No.
All right, we'll go through it real quick here. So tangent x is sine x over cosine x. Okay. And then we can rewrite this a little bit. What if we made this negative and we change the sign out here?
For what reason? Just to do it?
Because now we have u prime over u.
Oh yeah.
So if u is cosine x, u prime is negative sine x. Right? And then the integral of u prime over u is
ln.
ln u.
Oh, so just ln tan x?
ln no,
Cosine x.
cosine x. And then absolute value, remember? Yeah, you gotta keep that positive.
That's crazy how much it happened.
And there we go. All right. Our next one. This is another easy one.
X ln x.
So what are we gonna let u equal?
X. No, ln x.
Let's make it ln x.
It was ln x.
Yeah.
U is gonna be ln x here.
Because it just turns into ln x, right?
So notice here, x will have a simpler derivative, but it's a lot easier to integrate the x. So dv is going to be x dx.
X squared over 2 is d. Right?
du
Is x squared over 2.
1 over x dx. And v, x squared over 2.
So u times v, right?
So uv, and minus the integral of v du.
No, this is kind of a disgusting problem. We have to use the quotient.
Do you?
Oh, it's just x. My bad.
Simplifies.
That works too. Oh my God.
I'm going to pull out the half.
Integrate x.
X squared over x is just x. Integrate x.
X squared over 2, right?
Yep.
My brain is trying to comprehend. X squared over 4, right?
Mm-hmm.
Yeah.
Oh, I don't use history.
All right, so we've gotten a little bit of practice here. Now we're going to have, this one's going to be a fun one, a tricky one to take us home here. All right, so looking at this one in our cheat sheet, so it's E and a sine, so we're going to make sine the U.
Or you, this.
U the sine.
No, you're making sine the U.
I love math, it just sounds like you're speaking a foreign language. And that would make dv e to the negative x dx. Du is cosine x dx.
And then v equals negative e to the negative x.
Negative e to the negative x.
Negativity.
That's all.
All right, so we get
So u
UV.
and v, right?
Yep.
Negative
so sine x times negative e to the negative x
oh, this is kind of gross.
minus negative e to the negative x
This is really gross.
du cosine x dx.
So we have to use a thing again, right?
Let's see, we can pull out the negative, right?
Yeah.
And yeah, so we still have a factor here, or a product.
Isn't that the same? Isn't this kind of the same thing we just did though?
It kind of is. But now it's cosine.
Does that make a big difference?
Yes.
Well,
Why?
let's just give it a try.
How will it not keep going?
Apparently cosine is different than sine.
It is. Because the factor you pull out.
So we're thinking we might have this cyclical type of thing where it keeps going over and over again, and I'll show you what to do when this happens. Okay? It's going to be quite stunning.
Just look at this.
You say you stop it.
So,
dv
What do we let dv then?
e to the negative x dx.
E to the negative x dx.
Dx.
Negative signs are
So negative sine x dx. And then v is
Negative e to the negative x.
negative e to the negative x.
So u and v.
Okay. So we still have negative e to the negative x sine x plus
This is the same thing, pretty much.
uv minus the integral of
This is the exact
e,
same thing.
what is it, negative e,
It's
This would
negative
be
e to the
negative
negative
e
x
to the negative
times the
x.
negative sine x dx.
And then it goes like
It's a
negative.
negative.
No, negative.
The negatives cancel out and you have a loop again.
okay, so let's rewrite this.
Onto the third.
Oh boy.
Infinite.
Apparently it's the third time. I don't see
It's
it's
an infinite. This pattern never ends.
I know.
Use a funky equation 14.
Oh, do you?
Let's see, so the negatives cancel inside,
Yeah.
so we still have minus the integral of e to the negative
You
x
have to use what?
sine x
It's negative e to the negative x.
dx.
Sine x.
Is that
Okay.
so positive.
Now if you look at this, you'll see that this is
That.
this.
What?
So it's almost like looking in a mirror, right? When you go in mirrors on two sides and you keep looking back and forth, keep seeing the same thing over and over again. So it doesn't matter how many times you repeat this, right? It would keep going around in a circle. So here's where algebra can come in. Let's rewrite the whole equation. So never underestimate the fact that you're writing an equal sign right here,
Where's the equal sign?
right? Remember?
What's it equaling? Oh, that.
So let's rewrite it.
Oh, I see. Then you subtract.
You cancel it out. Oh.
Hooray! Hooray!
None of you write all this junk.
Because the rest
Okay.
of it's still there. It's just that one section that's canceled out.
So this is 1 equals, right? Or 0 equals. Yeah, 0. So,
Let's get to try.
did you divide or subtract?
You should
subtract.
So you want to add this to the other side.
Oh, so you get 2 of that.
No, you get 0.
No, you get a subtraction sign.
It's negative.
You get 2 of them.
Oh, on the other side.
Yeah.
So now we have 2 of them, right?
So then you just
Wait.
divide it by 2.
So that goes away, and you get 2 over there.
You divide both sides by 2.
Yep. And then divide both sides by 2.
This is great.
Well, that's the answer.
And that's the answer.
So that goes away. So that goes away because you divide by 2. And it goes over there. And then this is our answer.
That's weird.
And there we have it, integration by parts.
Oh, no.